What if everything we've been told about the origin of our universe is wrong? Imagine the repercussions of such a revelation. This isn't just an intellectual exercise, but a genuine line of questioning. This video signals our deep dive into the Big Bang Theory and its conspicuous inconsistencies. The Big Bang Theory, the foundation of scientific faith in the narrative of creation, vividly illustrates the birth of our universe. It is presented by a lot of famous scientists as an almost a factual account of the creation of our universe. The fact is, though, that the Big Bang Theory has lots of gaps that scientists themselves have uncovered, and the theory really doesn't hold together particularly well. The theory postulates that our universe started as a hot, dense point roughly 14 billion years ago. This point, commonly known as a singularity, expanded to form everything we perceive and comprehend today. Now here's the puzzle. What triggered the Big Bang event? The essence of science lies in cause and effect, yet this question remains unresolved. To address this, science introduced the concept of a singularity. In scientific jargon, a singularity is a point of infinite, where our understanding of the laws of physics break down, where the laws that govern our universe simply cease to apply. But let's not mince words. Tagging something as a singularity is a scientific euphemism for "we don't know." Intriguingly, not every scientist regards the Big Bang as the absolute commencement. Some theories suggest the possibility of our universe being eternal, without a precise beginning or end. Others propose that our Big Bang is simply the most recent in a series of Big Bangs. However, these theories, while intriguing, lack a solid scientific foundation. They merely postpone the question of creation rather than provide an answer, or they create an infinite regress. This brings us to an interesting viewpoint. A faction of scientists firmly believes that the question, what caused the Big Bang, is not within the realm of science to answer. They argue that it is a philosophical question, not a scientific one. However, this is not a satisfactory response, as it leaves a fundamental gap in the theory. It's like placing a band-aid on a wound that needs stitching. The question still lingers, and science, in its essence, strives to answer these questions, not leave them to philosophical conjecture. But the Big Bang Theory's gaps don't end with the singularity. In fact, they're just beginning to surface. Scientists realized that if the universe started with a Big Bang, then it should not have the uniformity we see today. Next, we will explore the mysterious concept of the theory of cosmic inflation, the theory that seeks to answer the uniformity we see in the universe. And why is this taking the wind out of the Big Bang Theory's sails? To further explore our cosmic origins, check out the book A Chorus of Big Bangs, available on Amazon. It provides a comprehensive view of these theories and their implications. Stay curious, keep questioning, and share your ideas and thoughts in the comments section below. Welcome back, Cosmic Voyagers, to another deep dive into the mysteries of our universe. Today, we're tackling the second part of our series. What's wrong with the Big Bang Theory? In our first episode, we explored the fundamentals of the Big Bang Theory and the questions it raised. Today, we're going to delve into one of its most controversial aspects, the theory of inflation. Picture our universe as a balloon. According to the Big Bang Theory, this balloon started as a minuscule, hot, and dense point, which then exploded, expanding into the vast universe we know today. But there's a major problem with this theory. If the universe was created by a Big Bang, then the universe as we see it today should be lumpy and uneven, right? But it isn't. The temperature of the universe is almost the same everywhere. So what gives? Enter physicist Alan Guth and his theory of inflation. According to Guth, our universe started very small and remained in this state for a period, allowing the temperature to be the same everywhere. Then, in an instant, it expanded massively, leaving everything perfectly smooth and uniform. The discovery of the cosmic microwave background, a faint glow of radiation that permeates the whole universe, provided some support to this theory. However, the theory of inflation isn't without its flaws. Firstly, what caused inflation to happen? There's no cause and effect. The universe just suddenly inflated, and scientists cannot account for why it did that. Secondly, how did the universe suddenly stop inflating at just the right time before it blew apart? Here's a snippet from an interview with cosmologist Dr. Jane Kelsey. The theory of inflation is like a band-aid to the Big Bang Theory. It solves some problems, but it introduces new ones. We just don't know what sparked inflation or how it stopped. It's one of the greatest mysteries in cosmology. Despite these unknowns, most scientists are stuck with the theory of inflation. Without it, the Standard Model of Cosmology, our best description of the universe and its history, doesn't work. As if having to shoehorn in the theory of inflation to make the Standard Model work wasn't bad enough, things got even darker and trickier for scientists. But we'll save that for our next video, where we explore the darkness in the universe that gives scientists waking nightmares. Before we wrap up, do check out the book A Chorus of Big Bangs on Amazon for more information on our cosmic origins. And remember, your thoughts matter. Share your ideas on the Big Bang Theory and the theory of inflation in the comments section. Until next time, keep pondering the mysteries of the cosmos. Welcome to part 3 in our series exploring some of the major flaws that scientists have uncovered in the Big Bang Theory. The Big Bang Theory is science's explanation to how the universe was created, but that the theory has gaps. One of the gaps relates to gravity, the force that keeps our feet on the ground and guides our planet in its celestial dance around the sun. The closer a planet is to the sun, the stronger is the force of gravity it exerts over the planet, and the faster it orbits the sun. The further away a planet is, the slower its orbit. Stars also orbit their galaxies, and they should behave in the same way as the planets do in our solar system. The further away the stars are from the center of the galaxy, the slower should be their rotation speed. But in 1974, astronomers discovered the speed of the stars in our universe did not behave in the same way. The stars out at the edge of the galaxy are traveling at the same speed as the stars in the center. At the speeds the stars are moving, the universe should just fly apart. But some glue was holding them together. But what was it? It was inexplicable. There simply was not enough matter that could be seen to stop the universe from flying apart at the speed the stars are moving. It only made sense if there was more matter in the universe creating more gravity, allowing the stars further away from the center to rotate as fast as the ones closer in. But where was it? All the atoms and molecules and particles that scientists were aware of in our universe just could not account for this extraordinary behavior of the star movement. Scientists decided that there had to be some unknown, mysterious matter that could not be seen keeping everything together. And the name dark matter was born. What was shocking was how much extra of this unseen matter was needed to match the behavior seen. There had to be 500% more dark matter than ordinary matter. But what is dark matter? Scientists again just don't know. They have tortured themselves for years and decades since its discovery, inventing new and exotic particles to account for dark matter. Particles with the names of axions and hooperons and such. They have hunted for them, doing experiments in underground mines and shafts, and even sending out telescopes in space to gather more information on what dark matter could be. But so far, it has all been in vain. Dark matter remains a mystery. Some scientists are beginning to wonder if there even is such a thing as dark matter. But cosmology needs dark matter. Without it, the Big Bang Theory does not hold together. If the absence of evidence of the invented dark matter was bad news, then a new problem scientists discovered in the late 1990s took things to a whole new level with trying to keep faith in the credibility of the model. Tune in to the next video, where we explore how the rate of expansion of our universe had scientists scratching their heads in utter bewilderment. In the meantime, for those who wish to delve deeper into our cosmic origins, search out the book A Chorus of Big Bangs on Amazon. Until next time, keep looking up and keep questioning. Welcome to part 4 in our captivating series exploring some of the major flaws that scientists have uncovered in the Big Bang Theory. As you may already know, the Big Bang Theory is science's best explanation for the creation of the universe, but it's riddled with gaps that keep scientists on their toes. One such gap relates to energy, and the discovery that led to this revelation is nothing short of a scientific thriller. Picture the year 1998. A graduate student named Saul Perlmutter is immersed in research, pondering a question that has puzzled humanity for centuries. Will the universe last forever or come to an end someday? At the time, the only two options seemed to be that the universe could slowly expand forever or slow to a complete halt and then collapse. If the Big Bang Theory was like looking back in time to see how the universe began, Saul was looking into the future to see if the universe would ever end. But the results of his research were completely unexpected. The universe's expansion was not slowing down, but rather accelerating. The scientific community was taken aback. Bob Nickel, a professor at the University of Portsmouth, perfectly encapsulated the surprise, saying, "I remember it being just incredible. All the astronomers walking around scratching their heads saying this can't be right. Surely this can't be right." This revelation was even bigger than the dark matter anomaly. None of the theories, not even Einstein's theory of relativity or quantum mechanics, could account for why the universe was expanding at such a rate. Scientists proposed the existence of a mysterious substance that was pushing the universe to expand at this rate. They called this new enigmatic substance dark energy. As they delved deeper into understanding dark energy, it became increasingly baffling. It seemed like the more the universe expanded, the more new dark energy was being created. This just should not happen, and the amount of energy required to meet the observations of a rapidly expanding universe was staggering. Our universe, it turns out, is made up of 5% ordinary matter, 27% dark matter, and a whopping 68% dark energy. The last two components are still a mystery to us. This means that the Big Bang Theory cannot account for 95% of what the universe is made up of. Claire Burridge of the University of Nottingham summed it up by saying, "The fact that our predictions are so far off from what we see tells us that there is something fundamentally missing in the way we understand physics and the way we understand the world." Clearly, the Big Bang Theory leaves much unaccounted for and is not as robust as we'd like to believe. But if you think this is mind-boggling, wait till you hear what scientists discovered regarding how the laws of nature work. Stay tuned for our next video, where we explore how the precision of laws of nature turned scientists from relying on evidence and facts to faith for the things they could not account for. In the meantime, feel free to check out the book A Chorus of Big Bangs on Amazon for more information on our cosmic origins. Until next time, keep questioning, keep exploring. Welcome to part 5 of our series, delving into the major flaws that scientists have uncovered in the Big Bang Theory. Today, we will explore the puzzling precision of the laws of nature, a mystery that even the Big Bang Theory struggles to explain. The Big Bang Theory is the scientific explanation for the birth of our universe. It's a story of extraordinary events, starting from an intensely hot and dense point and expanding over billions of years into the vast cosmos we see today. But even this grand story has its gaps, and one significant gap is the unexplained precision of the laws of nature. Scientists are aware of the vast unknowns in the universe. For instance, they know that about 95% of the universe is made of substances they have termed dark matter and dark energy, which remain largely a mystery. However, they are certain that the remaining 5% of the universe, including us and all life on our planet, is made from atoms, 92 different types of them. In the early stages of the Big Bang, there was just a gas made from only two basic atoms, hydrogen and helium. Along with this gas, there was also a force, gravity. The strength of the force of gravity was just right to pull the cloud of gas together, making it hotter and denser, until it eventually became a star much like our sun. As these stars contracted, the temperatures in their cores rose, helium began to react and produce other elements like carbon, nitrogen, and oxygen. Eventually, stars became unstable and exploded in supernova explosions, spewing out into the universe the new types of atoms that had been created in the heart of stars. These atoms then became part of newly born stars, which created even more elements. This cycle of life and death of stars has created the 92 elements that make up the 5% of everything that we can see. It is this cosmic recycling process that leads scientists to say that we are all made from stars. But all of this relies on some preconditions, the values of the laws of nature, such as the strength of gravity, the speed of light, the charge of electrons, the value of the cosmological constant, and many others. These laws were set by default automatically at the start of the Big Bang, and these values are finely calibrated to an unimaginable degree. If, for example, the value of gravity was even slightly different, stars would never have formed, no other elements would have been created, and the universe would have remained just a cloud of dust. But why are there these laws of nature? And why are they so calibrated, so finely tuned to allow the universe to come into being and for us to exist? To find the solution to these questions, scientists embarked on a journey that led them down a path they really did not want to go down. In the next video, we will delve deeper into the shocking discovery of how precise the values of nature were and how scientists had to reconsider everything they had learned up to now. For those seeking more information, the book A Chorus of Big Bangs, available on Amazon, offers an in-depth exploration of this fascinating topic. Until we meet again in our next video, keep pondering the mysteries of our universe. Welcome back to part 6 of our ongoing series, where we delve into the intriguing complexities and gaps that scientists have identified in the Big Bang Theory. This prevailing scientific explanation for the inception of our universe has its fair share of unresolved puzzles. Today, we're turning our attention to one of the most profound and contentious of these gaps, the question of Earth's and humanity's uniqueness in the universe. For centuries, we were enveloped in the belief that Earth was the celestial epicenter, the fulcrum of the cosmos, a notion born in the minds of the ancient Greeks and perpetuated for millennia. This geocentric view envisaged a universe with the moon, the planets, and the sun all pirouetting around our terrestrial home. It elevated Earth to the status of utmost importance, casting it as the universe's unrivaled gem. Yet advancement has a penchant for turning conventional wisdom on its head. In the 16th century, Copernicus ventured a daring proposition. He challenged the notion that Earth was the nucleus of the universe and instead posed that it was merely an orbiting member of an astronomical ensemble, circling a star in a galaxy, amongst a multitude of others. Suddenly, we were not the centerpiece, but just inhabitants of a celestial orb spinning in the cosmic wilderness. This humbling perspective, eloquently named the Principle of Mediocrity by Max Tegmark, an esteemed professor at MIT, reminds us that we might not be as special as we once thought. Fast forward to the 1970s, when the astronomer Carl Sagan instructed a spacecraft to snap a photo of Earth from the edge of the solar system. The resulting image, showing Earth as a tiny, insignificant speck of dust in a vast cosmos, further underscored our seeming mediocrity. We and our home planet were just lucky statistical flukes, lottery winners in the cosmic game of chance. However, recent scientific discoveries have begun to challenge this notion. As we've begun to unravel the precise values of the laws of nature, we've found that they must be fine-tuned to an exceedingly precise level for the universe and human life to exist. Some values are so specific that the odds of them occurring by chance are trillions and trillions to one. This revelation has sent shivers down the spines of scientists, suggesting that the universe may indeed have a structure, a design, a balletic harmony that couldn't possibly be the result of mere chance. So, what does this mean for the Big Bang Theory and for our understanding of our place in the universe? We'll explore this fascinating conundrum further in our next video. In the meantime, if you're keen to delve deeper into our cosmic origins, consider checking out the book A Chorus of Big Bangs on Amazon. Until next time, remember, the universe is full of mysteries waiting for us to unravel them. Welcome to part 7 of our series, delving into the intriguing conundrums and unexplained phenomena that challenge the Big Bang Theory. Today we take a step into the realm of cosmic fine-tuning, a baffling enigma that has left scientists scratching their heads for decades. The Big Bang Theory, the scientific narrative of our universe's birth, has its fair share of mysteries. One of the most profound of these is the intricate precision with which our universe seems to have been designed to allow for its existence and, remarkably, ours. The plot thickens when we turn our gaze towards the stars. In the early days of the universe, the first stars were simplistic entities, composed solely of hydrogen and helium. A marvel of cosmic alchemy, these stars then forged heavier elements like carbon and oxygen within their fiery crucibles. Scientists in the 1950s discovered that the helium nuclei combined to create carbon in a process that seemed more by design than chance. A similar pattern emerged in the formation of oxygen. Both processes, against all odds, were incredibly fortunate. But this cosmic luck didn't stop there. As scientists delved deeper, they found that numerous laws of nature, such as the gravitational constant, the speed of light, mass of elementary particles, the strong nuclear force, the weak nuclear force, and nuclear resonances, all appeared to be fine-tuned. These laws and constants, the very building blocks of our universe, interlock with extraordinary precision. If any of these cosmic dials were tweaked even slightly, the universe, as we know it, would crumble. This perplexing dilemma was aptly summarized by Nobel laureate physicist Arno Penzias, who said, "Astronomy leads us to a unique event, a universe which was created out of nothing and delicately balanced to provide exactly the conditions required to support life." For a time, scientists were content to label this fine-tuning as mere coincidence. But the mystery only deepened with the discovery of a new anti-gravity force, the cosmological constant. This force had to be fine-tuned to an almost inconceivable degree, to 1 part in a trillion, 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 trillion. Any deviation, and the universe would be so drastically different that human existence would be impossible. Faced with this confounding reality, scientists found themselves in a quandary. They could not accept the notion of a created universe, yet they were equally unable to explain the universe's apparent design. Join us in our next installment as we explore the intriguing theory that scientists propose to unravel this enigma, the Anthropic principle. This theory proposes a universe designed for life without necessitating a designer. In the meantime, if this series has piqued your curiosity about our cosmic origins, consider checking out the book A Chorus of Big Bangs on Amazon. It offers an insightful look into the mysteries of our universe's birth and its ongoing evolution. Until next time, keep exploring the cosmos. Welcome back to the 8th installment of our series, What's Wrong with the Big Bang Theory? Today, we'll explore the Anthropic principle, a theory proposed by physicist Brandon Carter. The Big Bang Theory, while a profound explanation for the birth of our universe, leaves some questions unanswered. Such puzzle is the precise tuning of the laws of nature, a conundrum that the Anthropic principle attempts to address. Let's delve deeper into the Anthropic principle and its elements. Despite its groundbreaking insights, the Big Bang Theory could not address why the laws of nature were set with such delicate precision. At its core, the Anthropic principle is about the and conditions of our universe. The first element of this principle is known as the weak anthropic principle. This suggests that the universe is for life simply because we can only exist in a universe that is suitable for us. If any different, there would be no observers to make such an observation. But this doesn't quite answer why the universe's parameters are set to allow us to exist. To address this, physicist Brandon Carter proposed the second element, the strong anthropic principle. This principle asserts that our universe must contain those properties that allow intelligent life to develop at some stage. Use of the word must stirred quite a controversy. It suggested that the universe was obligated to give rise to not only conscious beings, but beings capable of understanding the laws of nature. Further pushing the boundaries, physicist John Archibald Wheeler proposed the participatory anthropic principle. This principle goes as far as to say that by simply observing, we bring the universe into existence. That's right, we are not just inhabitants of the universe, but its creators, bringing it into existence not only in the present but throughout the past, all the way back to the Big Bang. But, as you might expect, not everyone agrees with the anthropic principle. The anthropic principle has its fair share of critics. Many within the scientific community argue that the theory, while intriguing, lacks sufficient substance. It offers a narrative that appeals to our human-centric view of the universe, but falls short in providing a concrete scientific explanation for the precise tuning of the universe's laws. The strong anthropic principle, in particular, with its assertion that the universe must bring forth intelligent life, has sparked considerable controversy. The idea that the universe is somehow compelled to create conscious beings capable of understanding its laws is a notion that many find hard to swallow. Thus, the search for another answer continues. Scientists are convinced that a more satisfactory explanation to the fine-tuning problem must exist, one that doesn't rely on seemingly anthropocentric assumptions. In our next video, we'll explore a new theory that attempts to answer these questions, but it requires a leap of faith as big as any taken by a follower of a traditional religion. Until then, if you're eager to learn more about our cosmic origins, consider picking up a copy of A Chorus of Big Bangs on Amazon. Welcome to the 9th and final part of our series of videos exploring the major flaws in the Big Bang Theory. The Big Bang Theory, as you may know, is science's go-to explanation for the creation of the universe. But there's a big problem. The universe, it seems, might have been specially designed for life to exist, with the laws and constants of nature so finely tuned that it goes beyond mere chance. This fine-tuning ranges to the tune of many trillions to one, a precision that defies the boundaries of coincidence. The anthropic principle theory was devised to account for this discrepancy, but the theory is spiritual in nature and had no real scientific basis. So scientists found themselves in a quandary. They had to find a logical way to explain the finely tuned laws of nature. Otherwise, they would have to accept the notion that the universe had a creator, which would mean turning their back on long-held beliefs. In the face of this conundrum, scientists found themselves in a desperate search for a theory that could explain the universe's design without needing a designer. And finally, after years of head-scratching, scientists believed they found the exact solution. Enter the multiverse theory, a concept that seemed to solve the fine-tuning conundrum. The brainchild of astronomer royal Martin Rees, this theory proposed an elegant solution to the mysteries of our universe. Imagine, if you will, not just one universe, but trillions upon trillions of universes, each with their own unique laws of nature. Our universe, with its perfect conditions for life, could simply be the result of a cosmic lottery. In this vast multiverse, it's not inconceivable that one universe, our universe, would have the precise conditions for life to flourish. In this way, the multiverse theory provided a lifeline for the Big Bang theory, offering an explanation for our universe's special design without needing a designer. It was a theory that seemed to save the day, a theory that offered an escape from the conundrum of fine-tuning. But did the multiverse theory solve all the problems? Unfortunately for scientists, it did not. Despite its elegance, the multiverse theory faced its own fundamental problems. First and foremost, it failed to explain the cause of the trillions of universes it proposed. If explaining the origin of our universe was a conundrum, multiply that by trillions for the multiverse theory. It was a solution that seemed to create a bigger problem than it solved. Secondly, the multiverse theory lacked evidence or testable proof. Science thrives on empirical data, but the multiverse theory offered none. There's no telescope that can peer into another universe. No scientific instrument could ever measure a multiverse, leaving us with a theory that's as elusive as a ghost. As we have seen over the last 9 videos, the Big Bang theory, despite its widespread acceptance, is riddled with gaping holes that scientists have tried to paper over or have not been able to provide any answers for. The multiverse theory is no different and relies heavily on faith for continued belief in it. Scientists often deride the holy scriptures of traditional religions due to their reliance on faith rather than evidence. But isn't science doing the same thing when it comes to the Big Bang theory? Something for viewers to consider. For those seeking more insights, do check out the book A Chorus of Big Bangs on Amazon. The book provides much more information on our cosmic origins. We hope you enjoyed these videos and would welcome your feedback in the comments section below.